Ladies and gentlemen, welcome to this lecture on smart mobility, where we will focus on electric vehicles. I'm Gautam Ram and I'm an assistant professor at the Delft University of Technology. In this lecture, we will first see what is smart mobility and understand what are the effects of large-scale adoption of electric vehicles, especially on the electricity grid. Next, we will discuss how smart charging and vehicle-to-grid can be excellent opportunities to help with grid management. As per the Sustainable and Smart Mobility Strategy of the European Commission, the objective of smart mobility is to achieve seamless, safe, and efficient connectivity through a set of sustainable mobility choices, which are increasingly driven by digitalization and automation. Hence, it is a crossroad between digital and transportation sectors that allows for an intelligent transportation system. The key drivers for smart mobility are zero emission vehicles, vessels, planes, and high speed rail, mobility as a service or MaaS, which focuses on shared mobility, and automated mobility, where vehicles can drive themselves safely and react to their environment. Electric mobility plays a fundamental role in the road towards zero emission vehicles and has many benefits compared to fossil fuel powered cars. With zero tailpipe emissions, electric vehicles, or EVs as they are called in short, can achieve zero well-to-wheel emissions when charged from sustainable sources of electricity such as solar and wind. Also, electric vehicles are 3 to 4 times more efficient than a conventional fossil fuel powertrain due to high efficiency batteries, power electronics, electric machines, and the ability to recuperate braking energy. Further, electric vehicles have lower noise and it needs much less maintenance overall as there are less moving parts. Finally, electric vehicles can be conveniently charged at homes or at a charging point nearby when available. If you look at the figures of electric vehicle adoption in the world, based on the International Energy Agencies, there were 11 million electric vehicles in the world in 2020, having seen a steady rise over the last decade. The more vehicles, the more is the demand for charging stations, and so the number of public charging stations, including fast charging, has also grown rapidly over the years, though not always in proportion to the vehicles. And most countries have set ambitious targets for EV growth. For example, the European Union aims to have no less than 30 million electric cars by 2030. The rapid growth of electric vehicles raises essential questions on whether the electrical grid and the grid operators are prepared to manage this increased demand in power and energy. For example, let us compare simple household appliances and the power they consume. At the bottom, we have electronic gadgets like mobile phones and TV that consume power in the orders of 10 or hundreds of watts. Next, we have domestic appliances like washing machines and ovens that consume 1 to 3 kilowatts of power. But this is nowhere close to the power levels of electric vehicle charging. Even those, for example, slow chargers, they can use up to 11 to 22,000 watts or 11 to 22 kilowatts of power, while fast chargers can be 50 to 350 kilowatts of power. This means that the future electricity grid will experience a significant increase in power demand due to electric vehicle charging. This will be in addition to the increased demand from other forms of electrification, such as the electrification of heating. Also, the charging process of one car will last several hours, which has a high probability of overlap with other cars charging nearby, which will further increase the power demand. This net EV charging demand can increase the loading of the cables, of the lines, the transformers, and could cause under-voltage problems in the transmission distribution network. This problem can worsen if it coincides with an already existing peak on the grid. At the same time, electric vehicles can also be the solution to this problem. Smart charging can help with this grid congestion management by shifting the charging time or adjusting the charging power based on the grid capacity and local loading conditions. For example, When the load on the grid is low, the EV charging power can be increased. Subsequently, if the load power increases, then the EV charging power can be reduced. Finally, the electric vehicle charging can be even stopped if the grid is overloaded and can remain so until the grid demand is back to normal levels. Another example is when there is a limited maximum power for charging cars. Then with controlled or smart charging, we can operate multiple charging points sequentially based on priority, or to adjust the power of each of the charging points to be within a maximum limit. Or each car can also be charged with different strategies according to the load and the priority. The final example, and my personal favorite, is the use of smart charging to charge electric vehicles based on renewable energy sources such as solar or wind. Doing so, we can make electric vehicles 100% sustainable. And we can even go one step further and use the electric car as an energy storage to balance the variable generation due to solar and wind energy through vehicle-to-X technology. This is because we can not only charge an electric vehicle battery, but also the energy in the battery can also be fed back from the vehicle to a home, to a load, and this is called V2G, V2H, and V2L respectively. V2X is a generic term that is used to include all such applications and is an example of how an integrated energy system can be created by coupling the mobility sector. The V2X technology has several benefits. First, V2X enables the storage of electricity in the car, especially from renewable sources. Second, V2X can be used as a backup energy storage, especially when there is a power failure. Third, V2X can also be used for peak shaving and congestion management. To explain this further about congestion management, you can see this example where the electric vehicle can be charged when there's an extra renewable generation in the afternoon, and they can then discharge via vehicle to grid to feed energy when the peak load occurs in the evening. Lastly, ancillary services like frequency regulation, voltage control using an electric car with vehicle to X configuration can provide an owner with a revenue stream. For example, using an EV battery with a 10 kilowatts of vehicle to grid power, a mere 100 cars can provide 1 megawatt of power for short periods of times when required. Such a virtual power plant can play a key role in future grids with large scale of variable generation from solar and wind energy. Despite all its benefits, there are still several critical challenges for electric vehicles. The purchasing price of an electric vehicle is generally much higher than fossil fuel cars, even though prices are drastically decreasing now. There is range anxiety when owning an electric vehicle due to the long charging times of the battery and a lack of sufficient charging infrastructure in several places. And concerning vehicle to X technology and smart charging, vehicle to X needs bidirectional chargers, which are usually costlier than a unidirectional charger. Also, the ICT infrastructure required standardization, legislation, business models that are essential for the implementation of vehicle to grid and smart charging are still under development and implementation. With rapid advances in technology, business, and policy, I'm sure we will overcome these challenges. So, to summarize, we are currently starting the transition to zero-emission vehicles, and electric vehicles will play a key role for this. This poses new challenges for the power sector as grid operators need to provide the increased power and energy demand over longer periods of time. Smart charging and vehicle to grid can help with this challenge by using the flexibility by shifting or delaying the power demand over time or even feeding power back to the grid. Specifically, the ability to charge from and store renewable energy by using electric vehicles as batteries can help make electric vehicles more sustainable and also facilitate a larger share of renewable energy in our electricity grid. Thank you for your attention.